Okay, taking a look at our 7.3 homework. In some ways, I think this is a little bit easier than 7.2. Because generally, truthfully, we really use the t-distribution for means and not the z. So the like the one stack crunch problem where you had to enter the population standard deviation, we don't have to worry about that here. We always have a sample standard deviation, and we work with that. So we're going to review a little bit of the t-distribution. Explain how to find a critical value for a t-distribution. Right? So for the t-distribution, what we would need would be alpha, the significance level, and then our degrees freedom. That's it, right? I need to know what's going to be impressive, right? Whether it's a one-tail test or a two-tail test, I need to know if this is the H0 and it's a right-tail test, what is going to be eyebrow raising for us, or if it's a two-tail test, and so on, just like we did in the last section. And then I also need my degrees of freedom. So it's just those two things. I don't need to subtract alpha from 1. That's something we would do with confidence intervals. We just need to know alpha, and we need our degrees of freedom, and we can move on. So we'll find the critical values for the t-distribution for particular degrees of freedom. If the hypothesis test is left-tailed, use the one-tail alpha with a negative sign, right? So the left tail, remember what they mean by that is when we look at that t-distribution, hopefully I still have hopefully I have this up here. Let's see. Kicked me out. Okay, sorry about that, guys. It kicks me out. But so we have a one-tail. If it's a left-tailed test, we're going to have to use a negative t. See how that t is negative? If it's right-tailed, we just look it up on here. So if it's a 1% significance level, we're living in this column. But if it's a left-tailed test, we need to hang out over to the left there. That's all that means. So it would be a negative sign. Okay. If it's right-tailed, use the one-tail alpha with a positive sign. Okay. And if it's a two-tailed test, okay, then what we have to do is we have to take that alpha divided by 2. Okay. So we have to, if it's a two-tailed test, think about what that means. Right? If it's a two-tailed test, our result could be significant in either value, in either place. So we do have on the t-distribution a two-tails column. If you look at it, you have two tails. It makes life really, really easy for us. And we can pick that, and then we would have a positive and negative sign. So make sure that's two tails alpha, not 2 alpha. Sorry about that. Okay, so let's look at number 2. Find the critical value. So here we can actually dive into one. And the rejection region for the indicated t-test level of significance alpha. Okay, so this is going to be a left-tail test, so we don't have to do anything fancy here. We need the area in the left tail, just one tail, to be 0.005. And we have 25 degrees of freedom. If n equals 26, we have 25 degrees of freedom. So let me see if I can find my chart. So one tail alpha, 0.005, we have to live in this right column, all the way to the right. This is where we're going to be. We need to go down to our appropriate degrees of freedom, which is going to be 25. So 2.787 looks like what's going to be our critical value that's going to allow us to reject the null hypothesis. If it's right-tailed. If it's left-tailed, we just change it to negative. So it's left-tailed, so we definitely need a negative 2.787. Let me just double-check that number. I don't have it memorized. Yeah, 2.787. Should be good. And since it's left-tailed, we have to tag a negative sign on that. Okay. Let's look at one more of these. Just to, we got to finish this one off. So determine the regions where we would reject the null hypothesis, right? So that's our critical value. We're going to reject the null if we're less than that. So we're only going to reject the null when we're less than negative 2.787. This would be for a two-tailed deal, and this would not make any sense. Okay, so let's try another one of these in case we didn't get the hang of that quite straight away. So this is a right-tailed test. Alpha is 0.05. So when alpha is 0.05 and it's one-tailed, we're going to live in this column here. Everybody see this where 0.9, I know sometimes my annotations don't come up, but one tail, 0.05, it's one tail because it says straight away here we're right-tailed. So thinking about this, if you are a visual person, we're going to consider something significant that lives in here. Anything that happens less than 5% of the time when that null hypothesis is true. That's where we have to look. So our degrees of freedom is 10, and the sample size is 11, and our degrees of freedom is 10. So we go down to 10 degrees freedom, 0.05 and one tail. Everybody see that that is 1.812. Okay, and since it's right-tailed, it's just the positive value. It's not two-tailed. We don't need two values. It's just one. Okay, so determine the rejection region. It's right-tailed, so we're only going to be impressed if it's greater than 1.812. Okay? Greater than 1.812. Okay, in that particular t-distribution, the t-critical is going to be 1.812, and we'll only be impressed if we're greater than that or above that value. Okay, so let's jump ahead to number 5. This next one's pretty similar there. Okay, state whether standardized test statistic T indicates that you should reject the null hypothesis. Okay, so our critical value is going to be 1.679, and it's just right-tailed. So if in part A T is 1.721, we would definitely reject the null, right? Because 1.721 is up above this. It's a right-tailed test. Let's try another one. Part B, if T is 0, we won't reject it. This is not impressive. This is equal to whatever the null hypothesis claim is. So we would definitely fail to reject it, and we would fail to reject it because it's less than, right? We're only going to be impressed here in a right-tailed test if we have a greater than situation. Okay, 1.588. Similarly, 1.588 would live around here somewhere, and we would have to fail to reject because he's not large enough. We have to get bigger than 1.679 in order to be impressed by that and reject the null. And the last one, negative 1.745, well, that's in a complete different direction. If it was a two-tailed test, we'd be okay. But again, we would fail to reject it because it's less. We need to be greater than 1.679 in a right-tailed test in order to be impressed. So that's not going to work. All right. So let's jump ahead to number 7. All right. Use a t-test to test the claim about the population mean. Assume the population is normally distributed. Okay, and again, we don't have to deal with sigma and entering that if we do some of these in StatCrunch, which eventually we will lead to. The null hypothesis, right, the claim is that mu equals 52,500. So if that's the claim, this has to be a two-tailed test. Right? It makes our lives really easy. Remember, the null hypothesis is always an equal sign, and that's what they're claiming right here. It equals that. So this is a two-tailed test. So that's the first piece of the puzzle for us there. Okay. What's the value of the standardized test statistics? So I'm going to let my calculator do this for me. We go to stat, we go to test like we've been doing for a while, and now this is a t-test. This is really what we would always do for means. Okay? And we do not have the data. We have the statistics that they're giving us here. They give us a sample statistic of 52,826. So actually he goes here. But remember, the claim value, should have just started with that, but I forgot what it was, is 52.5. Okay. So sample standard deviation, they ought to give that to us if they don't give us the data, and they do indeed. It's 1900, and sample size is 18. Okay, and I believe this is a two-tailed test, right? Yeah, we're just simply saying it equals such and such, so that's two-tailed. All right, so I get a statistic of 0.728. So to 2 decimal places, that would be 0.73, right? P-value, critical values. So critical values, we have to do what we've done previously. Our critical value, we're going to use 0.05, two-tailed test, and n equals 18. So let's see where that's going to live. 17 is our degrees freedom. Okay, it's a two-tailed test. So two-tailed 0.05 lives here in the middle. Right? So 17 degrees freedom, two-tailed, 2.11. Plus minus 2.11. Okay. So since 0.73 is not big enough to be above 2.11 or less than negative 2.11, we would fail to reject the null hypothesis. There is not enough evidence to reject the claim, right? We fail to reject. Not enough evidence. Anytime you fail to reject because there's not enough evidence. That's the way that is going to roll. So let me jump to numero 10 here. Test the claim about the population mean mu at the level of significance alpha. Assume the population is normally distributed. So the claim is that mu is less than 50/15. That's our alternate, right? It doesn't have an equal sign in it. So I'm just going to steal that. They're giving it to me. So if they're going to give it to me, I'm going to take it. Okay. So they tell me straight away that's the alternate. So the null has to be the exact opposite of that, right? It has to be mutually exclusive. It's going to have to be greater than or equal to 5015. Okay. It's our null and alternate hypothesis. Just steal them when they give them to you that easily. All right. So now we're going to run our t-test. So let's go to stat, test, and number 2 for t-test. Okay. And let's see what they give us here. So we want to find that test statistic. Our claimed mean is 5015. So that's our null hypothesis. Our sample statistic. We take a look and they tell us that X bar was 5217. And our sample standard deviation, they give that to us too. We have stats, it's 5837. And then finally, they ought to give us our sample size, which was 53. We don't have to go to 52 degrees freedom. The calculator will figure that out for us. And then for our alternate hypothesis, we can just look at what we put in. Our alternate hypothesis was less than symbol. So we picked the exact same symbol. Less than. No different. Okay. So my t statistic is 0.2519. So just 0.25 if we go to 2 decimal places. We don't have to worry about being off here because we didn't have to put in sigma and StatCrunch or anything. P-value is going to be right there for the taking, 0.598, but if we go to 2 decimal places, that 9 is going to bump up. So this would just be 0.60, I think, to 2 decimal places. Oh, 3 decimal places. Let's double back. 0.599 then, okay? 2 decimal places, 3 decimal places. We never know what we're doing here. Okay, so decide whether we reject H0. That's a really high p-value, And we know if the p-value is low, the null must go, so that's not low, we fail to reject. There is not enough evidence at the 2% significance level, it's kind of a weird significance level, to reject the claim. So let's see, the claim is that it's less than 50-15. We didn't have enough evidence to support that claim, right? The claim was the alternate hypothesis is a claim. So we don't have, if we don't reject the null, we can't support the claim. So just try to look for what the actual claim is, okay? Okay, sorry about that. I wrote 0.02 instead of 2%, right? So 0.02 is alpha, but that's actually 2%, okay? Sorry about that one, gang. Let's jump to number 12. Write the claim mathematically, identify H0 and H alternative, which of the following correctly states H0 and HA. Used car dealer says that the mean price of a 3-year-old sports utility vehicle is $2,300. You suspect it's incorrect. So this is a two-tailed deal. He says it's $2,300. You say it's not. There's nothing. We're not saying it's greater than or less than. Okay. So that's just a two-tailed test straight away. What's the critical value of t? In other words, what's the t value that's going to impress us in this particular case? So we have a sample size of 24. It's a two-tailed test, and alpha is 0.1. So we need to look at 23 degrees of freedom. So I go down to 23 degrees of freedom for two tails, and alpha is 0.01. Hopefully you can see this here. I'll try to point it out. 23 and 0.01 in two tails, 1.714. Oh, I'm sorry, plus or minus, right? When it's two-tailed, we have to put that plus or minus in there. Otherwise, they're not going to be happy with that. Okay. Determine the rejection region. Okay. So the rejection region is going to be when we're less than negative 1.714 and greater than positive 1.714. Okay. So what does that look like graphically, right? It's a two-tailed test, so they're saying this is the null. So we don't care if it falls out here or if it falls up here. Any one of those are going to be far enough away from that we're going to conclude it's not true, and we would go ahead and reject it. Okay. So now we got to actually run the test. Okay, so it's a t-test again. Number 2. So our null hypothesis here, let's go back and look at our narrative. He claims it's 2,300. Okay. You get a sample statistic of 2310. And our sample standard deviation, 23,000 and 23,810. Thought I could memorize it, and I couldn't. And then our sample standard deviation is 1999. And let's peek back at our sample size. 24. 23 degrees freedom. And again, we just don't think it's true. So it's a not equal to situation. Okay. So I get a t statistic of 1.985. Let's see how that measures up. 2 decimal places, so 1.99, right? And then finally, what would we do with that? So our critical value was 1.714. 1.99 goes above that, so we would reject H0 because the test statistic is in the rejection region, right? It lives up above. 1.99 is out here. He's up above that. So we would reject the null hypothesis based on that. Okay, interpret decision in context. At the 10% significance level, there is sufficient evidence to reject the claim. Right? That's exactly what we just did, right? We found that our test statistic fell past what we would consider to be, oops, let's see what we missed there. Oh, sorry, I didn't see the not there. There is sufficient evidence, oh my gosh, okay, yeah, to reject that claim. Didn't see the not there. Okay. All right, so let's jump to number 15, see what that looks like. Right. So now we have everything here in the narrative. So I want to test the claim that the mean amount of lead in U.S. cities is less than. So this is right-tailed, right? They believe that it's less than. So remember, this always has to be a equal to symbol. So the opposite of less than would be greater than or equal to 0.036. Okay, so this is the actual claim. They're saying that it's less than 0.036. Okay, so their claim is that it's less than 0.036. We don't need to read any further. We'll get the rest of this. We got our sample size. We got our sample statistic. The claim is in this case, the claim is the alternate hypothesis, right? They're claiming that it's less than. Your null hypothesis always has to have some incarnation of an equal sign in there. Okay. So find the critical value. So we need a sample of 56 U.S. cities. So that is a degrees freedom of 55. Let's see if we have that on our table. So I don't have 55 degrees freedom on my table. This is a little bit frustrating, but I do have inverse T on here. So we can go inverse T, and we want to think about this for a second here, right? This is a left tail test, right? It needs to be less than 0.036, so it's a left tail test. It's going to be negative. So the area, the value that we want for our critical value for 10% would be 10%. It's a left tail test, so we can just use our area to the right of 10%. Degrees freedom is 55. We don't have that on the table. So if they want an exact value for the T critical value, we'd have to use the calculator for this. So negative 1.297 or negative 1.3 if we go to 2 decimal places. Okay. And just to look at the table, see if we used 50 degrees of freedom, we would get the same answer. I believe that 1.299 is 1.3. So even if you use your table here, it seems a little tricky, but your one tail, we would still get negative 1.3 as our particular value. So don't worry if you don't have the calculator for that. You can still use your table. Don't use more degrees of freedom than you have. Use less. Okay. So where's the rejection region? It's a left tail test, so it has to be out there to the left. You need to see what numbers they have on that. And then our T statistic, if we actually run this test, we're going to have to go to stat test and run an actual T test. We do indeed have the stats, so we just have to enter them. So 0.036 was our null. Our sample statistic was 0.039. Our sample standard deviation, what happened there? It was 0.068. And our sample size was 56, but I'm not going to guess on it because I keep messing this up. Yeah, 56. So 55 degrees freedom. And this was a completely left tail test. We were trying to see if it's less than. Okay, so my test statistic was 0.33 for T. Okay, so I inadvertently lost that whole entire problem. I'm not going to redo it, but I'll roll through what we do here. Your test statistic is 0.33. Okay, that's your t-bit test statistic. It's one tail. Your p-value is 0.6287. We just round that accordingly. So what this means is that we would fail to reject the null hypothesis, right? But in this particular case, the claim was that it was less than that, right? So we're going to fail to reject the null hypothesis, which means we don't have evidence to support the claim, right? The null hypothesis was that it was equal to 0.036. We failed to reject that. Their claim was that it was less than that. So we don't have evidence to support their claim. Sorry about the inadvertent clicking here, but hopefully this was a helpful homework help video for you.